So you guys are lucky enough to actually get the first version of this talk ever. I'm the VP of Engineering at Greenhouse, as the little thing said earlier. Used to actually program all day. And I got really interested in the concept of schemas and how it might relate to the modern web. And so when I originally described my talk title, I used this thing, and I was actually kind of cracking up as I wrote the email to Dan because it was such a ridiculously technical talk title. Using JSON schema to enforce RESTful API contracts, I think was the original title. It's now Escape from the Tower of Babel. And so hopefully this will be more exciting with that title than it was before. And so I'm going to start by potentially confusing you a little bit. So what we'll talk about, primarily we're going to talk about foxclores, luzodines, mouse blitzers, but also Norastronomy, not to be confused with Norastrology, which is a quack science, Fufa pastarinos, and of course, hawkoons. So you're all well-educated people. I assume that you're familiar with all of these concepts, right? Everyone knows what a Fufa pastarino is. I can just move on into the depth. Of course, all of those terms were utter nonsense, except, of course, for Norastronomy, which is the science of the causal effect between Chuck Norris's spinning back kick and the formation of new galaxies. So the problem I'm actually trying to highlight is this. Our beautiful, resource-oriented, HTTP native RESTful APIs don't share a common language anymore. They're speaking different languages, and it makes communication really, really difficult. Our RESTful APIs consist almost entirely of neologisms, idioms, misappropriated concepts, and false cognates. So, our APIs are all speaking a glossopeia. And by the way, that last word is actually real. It is the act of creating a constructed language. And we are not all J.R.R. Tolkien. Our APIs are not made better by speaking Elvish to dwarves and Entish to orcs. So how do we descend this Tower of Babel that we found ourselves in before we are destroyed by our own creative divergence? To find out, we must descend the sedimentary layers of digital archaeology and dig down to ancient times. The year 1996, a time of 56 kilobit per second modems, Netscape Navigator, Season 3 of Friends, and Jenko jeans, which I owned many of at the time, and perhaps even further to begin our search for answers. So brief history of schemata, very brief, obviously 2 bullet points. Schema comes from the Greek word schema, which translates to form, so it's the structure of something. And the great German philosopher Kant in the 1800s took the term to mean a conception of what is common to all members of a class. So in programming, you all use types, whether they're duck types or static, polymorphic, Hindley-Milner. You expect an integer to be multiplicable by another integer, a string to be decomposable into an array of characters, and a bit to be flippable. These types are not wholly adherent to any standard schema across languages, but rather they are cognates of one another from one language to the other, and cognates reduce cognitive load. Schemata, on the other hand, offer the promise of eliminating that load entirely because you're then speaking about the same things. So let's talk about the internet's Rumspringa. And yes, that's an Amish dude crowd surfing. So Rumspringa is Amish for adolescent exploration. And though it had been in development since 1969, 1996 marked the year that the internet started being taken seriously as a platform for commerce, for artistic expression, and as a potential catalyst for deepening the very interconnectedness of humanity, right? So the W3C and the ITF and countless industry consortia worked tirelessly to prevent an impending catastrophe of mismatched protocols and useless heterogeneities throughout the platform of the internet as it assimilated orders of magnitude more users every single year. And as a result, we are blessed with something that, for the most part, actually works. Browsers can talk to servers, servers can talk to other servers, because they all understand the HTTP standard in roughly the same way. If each server and browser had implemented their own transfer protocols, as AOL did in the early days, then an extra adaptation layer would need to sit between every service and its client to translate Klingon to Cardassian and Ferengi to Bajoran, and thankfully we dodged this bullet. The W3C attempted the same feat in 1996 by introducing the XML standard, and along with an associated language for Schemata, XSD, right? Industries everywhere got totally engaged and started creating HR XML, Open Office XML, News ML, so that you started talking about the same things when you were within the same space. And for a few years, it almost looked as if we'd be able to communicate about the same concepts without the need for adapters, which would be super awesome, right? And how many people in this room have written an adapter in the last year to translate one API where you have some standard concept that exists in your universe as well and have to translate it into that other version that you have inside of your system? So almost everyone in this room, and it's a total waste of time. So the time needed to properly implement the full standard for any of these things, right? You had these gigantic monolithic XML schemas, was so great that you weren't able to get people and young companies especially to invest the time to properly adopt the standard. So what they ended up doing was writing schemaless XML for their APIs. I'm sure all of you have dealt with schemaless XML before, right? And thus an era of consistent inconsistency made its ominous return. Thanks to this guy. Enter Douglas Crockford, who is an amazing person, has done far more for tech than I will ever do in my entire life. He discovered JSON, right? This is something that was already in your browser, that already worked, and it didn't really require much of you, right? It didn't ask you to format things in a really specific way. You didn't really have to learn a bunch of new concepts in order to use it. It was just an object notation that already worked in JavaScript, and it was understood natively. So that's super sweet. I always hate XML. Let's start using JSON absolutely everywhere on the internet immediately without any additional thought given to the creation of standards whatsoever, and then keep barreling forward for the next decade, right? And no one actually had that thought, but that is totally what happened. And so schemata were kind of thrown out, and we threw out the baby with the bathwater. And there's the baby. So now I have to write adapters for everything I receive from anyone else forever and ever. And that's the current state of the world, right? And we work in an HR tech software platform, and we're all talking about people, right? We're talking about people, but we have thousands of different ways of expressing a person. First name could be F name, it could be first underscore name, it could be a string, it could be some encrypted, there's a million different ways of representing the same concept, and we did a really crappy job about communicating about what those are. Instead, we just went ahead and said, this is my word for it and you've got to learn it. So can you imagine trying to communicate with another human being where they've developed their entire language all their own, and you have to learn their language in order to be able to communicate? Every single person, right? We have groups of people who learn their own languages. How many people here speak more than middle school Spanish, right? Like almost no one. It's really hard to learn all of those different languages, and that's actually what we're doing when we communicate with each other on the internet without schemata. And so we now live in this world totally hostile to schemata. It sucks big time. Not only does it mean wasted work, it is an evolutionary anti-pattern for the internet, and people foresaw this really early on. And unfortunately, we ended up in this hole. So it means every time I communicate about a type of thing with some other company, I am faced with totally misaligned fields, types, and values, despite the fact that we're talking about the very same thing. This means that in both directions, in order to communicate, we have to write adapting layers between all of our APIs. By not talking, and this is actually the point, it's not just about JSON schema, which is a potential solution to this. By not talking for tens or even hundreds of hours about how to implement some concept that is familiar to everyone in the industry and create a common standard, we've produced tens of thousands, or maybe even hundreds of thousands of hours of wasteful work in trying to communicate, understand, and adapt parallel concepts across systems. It's bad for developers because they have to work on writing really boring adapters, and who here thinks writing adapters is boring? Everyone, right? And it's also bad for business because we have to set countless Benjamin Franklins aflame to create even the simplest integration between system A and system B. So let's stop the insanity. We need to put an end to this. We have the technology to enforce schemas in JSON already. We've obviously settled on JSON. It's easier than XML. We totally get it. There is stuff out there, and it's not that JSON schema is the only standard. There's an example standard of how we might be able to communicate in a consistent way. And one of the reasons that the internet works is everyone just accepted HTTP is the protocol we're going to use, right? There are lots of other better protocols, the Spidey protocol, right? There are other protocols that people have dreamed up that address the deficiencies of HTTP, but because we've all agreed we're going to speak the same language, it makes things a lot easier. And in America, we've, for the most part, and this isn't totally true, we all speak our own different languages, we speak English to each other, and that allows us to conduct commerce, to build relationships with each other, to make friendships. We have an agreed upon protocol for how we interact. Is it the best way to express beauty in the world? No, maybe that's French. Is it the most specific? Maybe that's Russian or German or something like that. But at the same time, we do have this amazing power as a mass by communicating in the same language. And so there are two big problems ahead of us that I would like to at least address for this little group. One is to teach you guys about JSON schema, which is something that you might have bumped into before, but I'm guessing almost no one has because it's not really popular. Heroku uses it, but not too many other people do. And we need to figure out how to create community around JSON-based schema standards. We need to be able to agree on what are these concepts and how do we create a structure that allows for communities to be created that can then agree on standards going forward. So first step, teach people JSON schema. So that looks an awful lot like JSON, doesn't it, right? Because it is JSON, and it is very meta. There's a simplified schema for a person, and I'll walk through it. So this is the schema itself. This is where you can go on the internet to go find this schema. That's actually not a real address, foo.com, not a real place as far as I know. There might be something there, but this is where you can go find that thing. The type of thing I'm describing here is an object, right? So it's got some curly braces and some stuff inside. And the properties that I'm expecting in the object are a first name and a last name, and they are of type string. And I require that you give me a first name and a last name. And so I have now described a first name and a last name wrapped up as a person. And if you send me this thing, I will always understand what it means, right? And I can validate whether that's true. So there's this word composable at the top. JSON schema is a composable JSON-based schema language, and it looks like this, right? So let's take a look at that. Composability. So everyone's kind of familiar probably with the concept, whether you actually know the term or not, right? Where you're able to take some complex thing and make it part of some other complex thing by reference. And so that's something you can do easily in JSON schema. That's actually quite difficult or impossible in most XML standards, right? So I have this $ref. Instead of creating a new person definition every single time, every time I reuse my total schema definition, instead I can reference this type of object and say I have a person field and the value of the person field must be conformant to this referenced schema. And so that means that I can then build up much, much more sophisticated things by referencing a single object type canonically on the internet in a publicly accessible way. And I can say required is user ID and person, and then it will recurse down to this thing, right, and say what is required inside of that schema is that a person has a first name and a last name. Right? And it's able to figure out what this type of object is. So it's dry, right? It's don't repeat yourself. You don't have to repeat bits and pieces all over the place, which is something that you typically see inside of XML. So that's good, right? It's a canonical schema for each entity type. And these are relatively simple examples of JSON schema, but let's take a look at how simple it can get. So here's super simple, and this is totally valid JSON schema. I have an HTTP status code. It is of type string, and that is a valid JSON schema, right? I don't necessarily have to refer to it somewhere on the internet. This will validate that I get something called HTTP status code as a property name, and the value is something of type string, right? Totally valid, real, simple JSON schema. Validation. So it actually allows me the power to add more validation. I realize this is a super busted regex. Could have written a way better one, but I just wanted to keep it simple for the example. So the regex can then say, in order for this string to be valid, it must be a 3-digit number. Right, with numbers 0 through 9, which, I know, busted regex sucks, whatever. So, Here's maybe a better version, super simplified again. There are way more status codes, including is my tea kettle ready in HTTP, and that's totally real. I think it's status code 421 if you want to look it up. And so here I have enumerated types, right? I have a 200, a 403, and a 500, and these are all valid HTTP status codes that my system will understand, totally enumerated, no additional regex validation required, and I can tell that I've gotten a valid status code back and that this is a valid thing. So if I have something like this, right, and I receive this via my API, and I type this in Keynote, so the quotes are not valid. Do not copy and paste this. But in any event, this is actually 100% totally valid JSON schema. So this is something that will validate against this schema that I've defined. I'm expecting a number, and I'm expecting it to be one of those numbers that is valid. If the number were 404, because unfortunately I didn't include it in my enum, then it would not validate against the schema in the first place. So obviously having conforming schemas that others can reference for common things is great, but what if I'm only using an internal API, right? You're not always communicating with other people. Is this actually useful when I'm doing my own internal API development? So let's talk a little bit about how JSON schema could save you time. Automated API tests. So has anyone in this audience, and hopefully I think it's true that many of you have, written loads and loads of automated integration tests to validate the output of an API that you've written? Oh yeah, totally, right? Tons. And what are you checking? You're checking like types, values, structures, nesting. All you have to do is declaratively describe it inside of a schema language like JSON schema, and then the validator will do all of that checking for you. It's exactly the same thing every time. That's the purpose of a schema, to be able to validate that the structure is as you have declared it, right? Rather than write those tests over and over again. So I must regrettably inform you that all of this work that you've done over the course of the last 10 years to write tests against your APIs that are checking for types and values and formats and all of that has been a tremendous waste of time. And I'm sorry to say that. So, so you can see how this relates to JSON, but what does JSON really have to do with REST? And REST was part of my original talk title, right? Like we want to validate, make sure that we create RESTful API endpoints and have schemata in order to validate that it is truly RESTful. JSON itself has very little to do with REST, right? So it would probably take you, just as a quick detour, 30 minutes to an hour as a developer to master JSON schema. It's not that big. It's really small. There's a couple of reference pages, and you could start doing this tomorrow. And the validators are already written. The plugins into just about every popular language are already written. So welcome to JSON hyperschema. And this is going to allow you to actually enforce RESTfulness. So JSON hyperschema is a JSON schema-based language or standard that will allow you to ensure that your RESTful endpoints behave the way you want them to. So typically a hyperschema, which is just another type of JSON schema, will allow you to filter out malformed requests at the middleware layer. So for instance, inside of Rails, there's a gem called committee, and committee is a rack middleware that will allow you to enforce that the method is what you expect, that the media type and encodings are what you expect, and it can also validate whether a nested schema definition as part of this definition actually works. So here's an example, right? I have some href, I have some path, and these are actually parameterizable. I could say apple slash, curly braces ID and say this is a valid URL structure. I'm saying that the method that I receive at the HTTP layer must be a post. I'm saying that the target schema for the thing I receive is referenced here on the internet, right? And so if there's some failure, somebody makes a call against your API, one of the potential response scenarios when you're using a schema is to say, here's the schema. Right? Like, it has failed, here's the schema, this is your exception specifically, and this is how you make it conformant, and give them something that they can test locally to make sure that it actually works. For some reason, no one does this, right? All this technology is kind of already there. And to be perfectly weak about this, Greenhouse doesn't do this. We don't even do this, because no one does this, right? This is probably something we should start doing. It's something I've started thinking about a lot more, but this is a deeply unpopular yet incredibly useful concept. And so I just wanted to follow up by saying, Now that shit is RESTful. This is a way of enforcing RESTfulness that you can bake right into your application. And that's ideally what you want. So dang, easy. What's the catch? So in isolation, JSON schema and hyperschema deliver value by saving us the, let's say, 20% of API development time that goes into automated testing, which is super cool, but the biggest gains that will happen when APIs that we integrate all start using the same schemata is that we're all speaking the same language, we don't have to keep writing adapters. So this would be a super valuable outcome, but it does require interacting with other human beings, which is something that engineers are often reluctant to do, including myself occasionally. And many of those human beings are likely to vigorously disagree with you. It requires community organizers to reach out to competing organizations and get them to agree to a common higher purpose for the benefit of all. Organizers who can serve as team builders, rational moderators, solicitors of divergent opinions, and reconcilers of differences are needed across each industry to come up with shared canonical definitions for things that they communicate about in their respective universes. And in my world, that's candidates, applications, jobs, and resumes. So if anyone wants to talk that's building an HR system, I would love to come up with a standard where we can start talking to each other in the same language. So if you're in some other industry, you're in media, you're in finance, you're in the vending machine business, you could start and lead a committee to get started and start paying down the debt we accrue each day by failing to communicate with our competitors, our partners, other people we interact with in our industry about how to define, validate, and share the concepts that are common to our respective worlds. And that's it. Questions? Yes.
As you know, in the financial community, there's a lot of data exchange.
Oh yeah.
Things like fix and all these other things, are they now have the committee set up and move that to JSON?
I mean, there may be no incentive to move it to JSON. If everyone's already speaking a common language, then you don't necessarily need to change it just because it's not ideal. And maybe it is ideal. Maybe it was purpose built for finance and works really well for that use case. I'm not saying JSON is the right thing to do, but it is the thing that we are all doing. And so maybe we can accept that and then move on to how do we then do this in a more consistent and better way. Yes?
We saw XSDs.
Yeah.
We saw how they tried to solve the problem for XML. And it really didn't work because when you have to have more than 5 people in the room agree upon something, it's a big process. And then if you need to change that, although it might make a lot of sense to change it immediately, it is still a big process. Why do you think JSON is more?
I think it's a little bit simpler because it's composable. That's the only thing it's got for it. Is it going to have the same problems as these XSD committees? Absolutely, yeah. Right? It's really, but when you de-scope things, right? When you try to get somebody to agree on how to build something really big, it's really hard. When you try to get people to agree on how to build something really small and atomic, it's easier. And so that's I think the theory about why it's possible that this could work better than XSDs. Yes?
Quick follow-up question. But why do you think it's not going to introduce the same fragmentation you're trying to solve?
To have a bunch of composable...
Smaller schemas cause the same problem we have today.
Yeah, no, I mean, you probably have to have hierarchical organizations where it rolls up and there's an approving authority and all of that. I think the greater problem I'm actually trying to highlight is that we don't even try. Not that it's easy, and we've been negligent about doing some easy thing that's sitting in front of us, although for internal APIs, arguably it is pretty easy, and we have been kind of negligent, including myself. But I think community organizing is hard. It will be hard forever, but not even trying. I mean, if no one tried to get people to agree on any language, we would all be saying ooga ooga to each other at this point right now, right? So like, it's good that we had some crazy like warlord 7,000 years ago who was like, the word for pineapple is fucking pineapple. And if you don't say pineapple, like, that's it. Yes?
So you framed a lot of your talk around the fact that partner conversations is difficult and that touch point is where the communication breakdown happens. But you just mentioned actually like internally APIs is a lot easier because you can just go to the next guy in the other queue and say, hey, we talk in this language. Do you still see this as beneficial, internally within an organization, silo to silo, or?
Totally. I mean, I think there's less contention, right? You have local authority figures who people respect across divisions in most cases, not always within an organization. You save time on automated tests automatically. So like, there's no good excuse for not saving time on those tests. Those tests suck. They're a total waste of time. We already have schema validation engines, and it's way quicker to write a totally declarative schema definition than it is to test all of the different properties of every single bit of API output. I mean, we have tons of tests that do exactly that, but now I realize retrospectively, like, this would be way easier. And if you expose the schema, you expose the contracts, you say this is something we're going to use, when you do a good thing inside of an organization, I think other people latch onto it, right? So Aaron, actually sitting in the back of the room, is a tech lead at Greenhouse, and when he came in, we were building stories that were a bit too big, and so it took a long time for things to ship, and there was a lot more rebasing and merging and stuff like that that had to happen in order to get something out the door. And then, without asking anyone's permission, he just started cutting things into smaller stories and started shipping them. And now everybody in the organization is cutting things into really granular pieces and shipping them because they observed, hey, that's a successful practice that makes my life easier. I'm going to start doing that. And so I think this could be something like that, right? Where it's like, I just saved 15 hours writing these awful tests that no one likes to write for validating this type of information. Instead, I wrote the schema in 20 minutes, I ran it through a validator, and I'm done, right? That's pretty easy to get to catch on. People like saving time. Developers are lazy. It's good. Yes?
So one thing I thought about when you were talking about XML and how to research to JSON was what sucked about it so much was just, it was a lot more data to kind of send over the wire, and that was one of the benefits to JSON, I remember back in the day. So with this JSON schema, you have links to schemas, and that's like, you mentioned that scenario where you potentially fetch that schema if there's some sort of error. So imagine a case where you have lots of different associations and you're having to fetch all these schemas, there's additional requests. Is there a way to kind of handle that? Yeah,
I mean, if you know you're programming against an API, and this is all theoretical because no one really does this stuff, right? So if you know you're programming against an API and you publish your set of schemas in some RESTful way, and you have a GET request for your list of schemas, you can download them all in advance.
Right.
And then you
change, so it requires like versioning.
Cache invalidation is easy, dude. Like, let's just, I'm just kidding. No, yeah, I mean, you could check for a change. You could be making requests and just make sure that your file has the right headers set, so you don't actually have to pull down the entire asset every time. Instead, you're just saying, do I already have this? I've already got it. Like, we're good. I have the freshest version.
Foresee that.
No, I mean, it totally could be a potential issue. I don't think that schema validation is going to be a significant proportion of bandwidth, because let's say that you get it working, you've downloaded it once, you set up some polling interval, you get a new version, you see it breaks, you go get a new version. There's maybe some cache invalidation logic that you have to deal with around that stuff if you don't hit it every time. It's probably beneficial to do that in certain cases, but that's the same with any remote resource on the internet, and this happens to be a potential remote resource that could update independently.
So now you just have to worry about naming things.
Yeah, and naming things, right. Naming things, and then I think also the second one is off by 1 errors, right? No, that was a really deeply veiled joke, I'm sorry. Yes.
So you mentioned versioning. Does the scheme have its own, if I want to version up my objects,
Totally. Check this out. -01.
Okay.
-02 would be a different version, and then you've got it.
A way to declare that I'm dependent on schema, like less than or greater than, or
I don't think there's an equivalent like gem file for JSON schema yet, but I'm sure if you built it, there would be like massive adoption immediately, because it's been stagnating for a really long time. Whoops. No. Oops. All right. Well, I mean, you saw my thank you slide. So there, it's back. Yes, in the back.
This is the line between like schema and useful documentation that is like these people are.
I think schema is something that a programming language can understand and a human can understand. Documentation is something that only a human can understand. And so I actually think it's better to use schema than documentation. Just sort of like if you write code that is literate and easy to understand and read, that's better than writing a comment about what the code does and naming your function X, right? Or F, I suppose. Yes?
Have you looked into anything like API Blueprint, which allows you to do like documentation and then gives you the schema kind of for free once you define?
I haven't looked at API Blueprint, but in writing this talk, I figured I'd check what else was out there, and there are hundreds of projects like this, which is one of the problems. The difference with JSON schema, and one of the reasons I brought this up, is that this is an emerging IETF standard that is kind of languishing. So when the IETF or the W3C say this is something that we might actually endorse, that's better than like random dude in Iowa with no support and no community, like writing their own awesome thing. API Blueprint might be super well adopted, I'm not familiar with it, but there are so many people trying to solve this problem, and we all kind of have to agree on something, even if that something is suboptimal.
I meant more like, because it generates this, the API, it uses JSON schema and it generates it for you once you define.
Oh, it uses JSON schema? Oh, no shit.
So like,
yeah, we should totally use that.
And you define what the data structure is in a response, it will generate like the sample JSON and then the JSON schema for it and link it for you. So that might be something that might actually get people to adopt.
Yeah, totally. Everyone listen to this guy and download and use API Blueprint. Forget everything in this talk. 100%. No, that sounds better. If you have something that does more automatic awesomeness, then you should do that.
Yeah, open source.
And it's free. The price is right. Get it while you can.
All right, let's call it a wrap. One last big round of applause.